Hello everyone. In this video we shall see the various characteristics of Internet of Things. To begin with, first and one of the most important characteristics of the IoT devices include dynamic and self-adaption. Basically, this is one of the characteristics which is very important for any IoT devices, because IoT devices are mainly used dynamically, and it's not possible for any human being to manually change towards the different environmental conditions. So it's common, always it is common that all the IoT devices must automatically, dynamically change their settings or adapt to the environmental situations. For any kind of changes in the context, an action has to be taken for the operating conditions, user's context or sensed environment. Let's take an example to prove this dynamic and self-adapting. We have surveillance camera which is connected everywhere in the building, and it is an example for IoT because the surveillance camera can be monitored or can be handled remotely by using any mobile applications. So these surveillance camera are working both in the daytime as well as nighttime. So a lot of changes required when a surveillance camera is working during daytime. At the same time, a lot of changes required for a surveillance camera to work in night mode. Basically, when every camera is working during night mode, it is working with help of an infrared camera. So in the daytime, all the cameras are working in the normal mode. So this self-adaptation for a surveillance camera based on the environmental condition dynamically is one of the major characteristics of the IoT devices. I have given only one example. Like this, you can have a lot of examples. I would like to give one more example related to the same surveillance camera. Say the surveillance camera activities can be recorded by using any DVR. Normally what happens is the surveillance camera works at a low resolution when there is no movement observed from the camera. But the moment the movement is observed by the camera, it automatically switches over to the high resolution for better detection and to give an alert which is nearby to the camera. So otherwise, when there is no mobility, there is no need of high resolution camera, because the more resolution, the higher the resolution, the DVR needs a space, more and more space to store it. Unnecessary, it doesn't want the wastage of the storage space. So what does it do is, it detects the movement. Only when it detects the movement, actually we require a surveillance camera. So by that time, you require a higher resolution so that the camera automatically switches over from, it itself adapts, switches over from lower resolution to the higher resolution, so that here also we can expect a dynamic modifications or dynamics adaptation. It self adapts the settings of the cameras based on the context, based on the conditions. Another characteristics of this IoT, self-configuration. Basically, IoT devices may have self-configuration capability, allowing large number of devices to work together to provide certain functionality. So, for example, as I mentioned, weather monitoring. So we have IoT devices which should self-configure themselves because we have a large set of IoT devices wherein most of the time what we say basically it is a feature or it is a characteristics which is taken from a concept of plug and play, which is very essential and which is currently available in most of the operating systems. The concept of plug and play is the moment you connect any device, the operating system will detect that device. Automatically it configures. Very rare we require the manual intervention. So you connect your mobile phone to your Windows laptop. Automatically a message pops up stating that you have connected the mobile device. You might not be knowing what is that configuration of the mobile, but definitely the operating system will say this is the company of the mobile you are using, this is the model which you are using. So a lot of details which are given by the laptop itself, because the moment you connect the mobile to the laptop, it self configures like this. Various IoT devices also have a capacity of self-configuring so that minimum manual or user intervention is expected. So that's a good characteristics. Otherwise, human intervention, if it is more, he finds it very difficult to configure because a lot of activities are required, and for every now and then, he doesn't find it easy to configure. So today, all the IoT devices have a capability of self-configuring whenever they are connected to internet, whenever they are connected to any system, whenever they are connected to any storage locations. Even in the cloud platform also, IoT devices are able to configure themselves in sharing the data to the cloud or in collecting the data from the cloud. So they have a capability of self-configuring also. And another characteristic of the IoT devices include interoperable communication protocols. So here one very important point I would like to mention that most of the IoT devices need internet, need communication network and need internet service providers for communication. So we think of different types of IoT devices wherein each IoT device may use its own style of protocol at a higher end, but normally when it comes to the lower end, it is using the same IP principles. Maybe IP protocol is concerned, transfer TCP is concerned, any other lower protocols are concerned, it is using the same protocol. But when it comes to the higher level protocol, each device may have its own communication protocol, which makes it operable. So now the problem comes, now the challenge comes when one IoT device wants to interact with another IoT device. So IoT device A is functioning in a different communication protocol. IoT device B is functioning at a different communication protocol. So these should communicate, they should share the information, and the information should convert into knowledge so that you need in an environment in such a way that an IoT B should understand what IoT A means. IoT A needs to understand what IoT B means. So all these are possible only when IoT devices support interoperable communication protocols. Say these protocols enable smooth data exchange and coordination among the heterogeneous devices. So basically here one more point, we should understand that IoT devices are not homogeneous devices, heterogeneous devices. So you require the protocols of heterogeneous devices to operate among themselves. So interoperable communication is possible from the uh, IoT devices. Now, next point to discuss here is unique identity. Yes, it's very important. As we already have studied that communication requires all the participants to uniquely identify. Your laptop also, whenever it is connected to internet, should uniquely be identified, or your desktop, your machines in the lab, all of them should be uniquely identified whenever they are connected to the internet. So like this, even IoT devices also has a unique identity and unique identifier like an IP address or a URI, so that a single address need not be given to multiple devices. So IoT systems may have intelligent interfaces which adopt based on the text, allowing communication with the users and environmental contexts. So they have intelligent interfaces. As I already told, it's not a door lock which is automatic. It is an interface which is connected to the door lock with the help of an application software, could remotely handle, or it could handle the door lock. So these interfaces are connected to the internet, and of course they use a communication protocols so that they are identified uniquely. So the IoT device interfaces allow users to query the devices, monitor their status, and control them remotely. See, query their devices. What devices are there? So, do you have a camera, surveillance camera? If there is a surveillance camera in a house, how many surveillance cameras are there? So, query is there. How many devices are there? Then monitor their status. Whether the camera is working, whether the camera is getting the pictures, whether the camera is running its lower resolution or a higher resolution. So whether the camera during night is working in an infrared mode or not. So you can monitor the condition, monitor the status of such camera, and you can even control them also. See, for all these activities, you have to make all these devices identify uniquely. It's one of the characteristics, so that you can control, you can configure, and you can manage the infrastructure of the same. Moving on to integrated into information network. That's one more characteristics. So IoT devices are usually integrated into information network that allows them to communicate and exchange data with other devices. Already mentioned, IoT devices are handling interoperable protocol based on multiple devices. So you require integrated information system. So integrated information network is required, so that allows these devices to communicate and exchange data. So this is one of the important characteristics of the IoT based network communication. So IoT devices can be dynamically discovered in the network by other devices and other networks, and have capability to describe themselves. So I can handle my door locking system. If I convert that door locking system into an IoT based door locking system, I need not be connected to the same network where the integrated information system is connected to that network. I can operate it from anywhere in the world. So it's not that I should be connected to the same network. I can be from a different network. I can discover it from the different network, or I can discover it from other devices or other network, so that I can do all the activities with the help of the user applications. So it is integrated into information network. An example for the same is a weather monitoring node can describe its monitoring capabilities to another connected node, so that they can communicate and exchange the data. So one node can be connected to another node. Both are belonging to different networks. So they are integrated into the information network, which helps in making IoT systems smarter due to collective intelligence of individual devices in collaboration with the infrastructure. So when we have this monitoring system spread out in different networks, everywhere it is IoT device which is getting the details of the weather, and this has to be collaboratively integrated so that some information can be, some application can run on it, and people can see that future prediction. Thus, the data from the large number of connected weather monitoring IoT nodes can be aggregated and analyzed to predict the weather. See, this is what is happening. See, prediction of the weather is not a simple task. It requires a collection of data from a large number of connected networks. See, it's not that it is going to rain at Udupi just by taking a small data from an IoT near to the Krishna temple or near to the Udupi bus stand and then coming to the prediction. It's not so. So if at all they want to say that there might be a rain tomorrow, by collective collection of the data from the large number of connected weather monitoring IoT spread out in different parts of the workpiece, so that prediction can be done based on the collective details from the data. So that's the reason why integrated into information. So they need to be integrated so that they can get the collective data. So this is one. Now let's look into the generic block diagram of IoT devices. So how we can think of IoT devices. So IoT devices basically contains a processor. It's the heart of it. And whenever there is a requirement of display, there is a graphics connected to it, and any kind of connectivity. Basically, IoT devices need the connection. So if at all IoT device need a connection, it connection could be done using a USB port, or connection could be done using your normal internet cable, that is RJ cable. And definitely IoT devices require the memory. So it could be NAND or NOR based memory, or it could be DDR1. Basically nowadays we have DDR3 memory for the internal operations. Then we have audio video interfaces also. So we have audio interfaces. For video we have either HDMI. So only for audio we have a small audio jacket, a stereo jacket, 3.5 mm. So 3.5 mm is a jacket which is connected to any audio devices. It could be RCA for a video, or even HDMI also. It's a collective. It contains both HDMI audio as well as video interfaces, where that could be connected to the displays or any other output devices. Then if we want, normally in some of the for example, if I say the sensor cameras, so if we buy an individual camera, there's a small slot available to connect the SD card to it. So in addition to the internal memory, there is a capacity and there is a provision for connecting the storage informations or interfaces. So wherein you can use an SD card, we can use MMC, we can use SDIO. Nowadays it's all very small port is available, very small MMC could be connected to it, which can store the data. Now for the actuators and for the sensors, we required IO interfaces, which there are different types of IO interfaces. UART is there, SPI is there, I2C is there, CAN is there. So these are all the IO interfaces to the IO devices. So connectivity we have RJ and USB. Then for IO interfaces, for the sensors to be connected to the system, for the IoT system, we require UART, UART, SPI, I2C or CAN. So like this, different connectors we require, interfaces we require. So we have seen the different parts of the IoT devices. Some parts are taking responsibility of connectivity, and the main part being the processor. Another part takes care of audio and video interfaces, then IO interfaces, internal memory, graphics, then optional storage interfaces. Suppose if you want to store the details, you can store them using some external storage devices. Now, the things in IoT, Internet of Things, the things. Here, the things in IoT usually refer to IoT devices that have unique identities and can perform remote sensing, actuating, and monitoring capabilities. So they are sensors, they are actuators, they are monitors. So IoT devices can exchange data with other connected devices and applications. As I already know, interoperable devices. They can exchange the data with other connected devices. They can exchange the data with other applications. It could be direct exchange of data or it could be indirect exchange of data. Means a sensor is sensing some data and then interface program or interface is going to convert it into in another form, and this data could be gone to another device with the help of an application program. So using this indirectly, this device could exchange the data with other connected devices. Directly it is also possible. So they interconnect, like if I take an example of IoT sensors, a sensor-based irrigation system. So in the sensor-based irrigation system, if a sensor feels that a pump has to be switched off, directly it sends the data to the interface device, and this interface device, with the help of a program, is going to shut on the pump so that you can directly handle the devices, the data collected from the devices. So it could be direct connection or it could be indirect data. And even you can process the data with your local machines, with your local network, or you can process the data with the help of the centralized servers. For suppose if I want to, for example, if I want to, I have my car, this I have my car. This car is going to give me a alarm, a harmful alarm. So when I get a harmful alarm from my car, I will be totally at a remote place. So when I am at a remote place, I need the help of a centralized server which gets the data from my car and passes it to cloud-based application, and then through the cloud I will be able to get the information in my mobile phone, so I can take any decisions later. See, in this case the data is indirectly connected, not directly connected. It takes the help of the centralized server. Its cloud-based applications are required for processing the data. So it's a complicated architecture. Here also, data is getting shared from the IoT with the other parts of the unit. So they may also perform some tasks locally and other tasks within IoT infrastructure based on temporal and space constraints. Like memory constraint might be there, processing capabilities might be there, communication latencies might be there, and speed matters a lot, and then deadlines. So these are all the various constraints wherein the IoT devices need to perform. So as I already told, the block diagram of IoT contains IO interfaces for sensors, interfaces for internet connectivity by means of RJ connectors, memory and storage devices, audio and video interfaces. So IoT devices can collect various types of data from onboard data through sensors. So, onboard data. See, these are the data which are there on board. It cannot be remote. So there is an interface which is designed, which gets the data from my humidity, temperature, light intensity. These are all the sensors which are connected directly on the board. If I want to give a very simple example, normally a simple do-it-yourself DIY electronic projects will be available. So wherein you want a street light, to switch on only during night time, not during daytime. So there you require a light sensor, LDR, light dependent resistor, which is acting like a sensor, so which is directly connected on board, and the data from the LDR is sensed. A small circuit is designed, and this circuit is going to control the relay switch. So relay switch is controlled by means of an LDR, which is a sensor, and all these devices must be connected on board using LDR as a sensor. So these sensor data can be communicated either to other devices or cloud-based storage or services, depending upon the requirement. So these data can be communicated. Suppose, for example, in case of the street light automation system, you don't want the data to be communicated for in a cloud-based storage or server system. You would develop a relay mechanism then and there only. You require the vicinity of that particular sensor limited only to the on board control. Everything is done on board, so automatically you are able to get the things done. So it could be on board or it could be cloud based. As I told, your vehicle's information can be monitored by using your mobile application. So under such condition, the data sensed by the sensors will be traveling over the network, over the cloud, and it is made available on the sensor. Simple example, if you want to get, suppose if there is an engine failure. So indication from the engine failure is given at the dashboard of the car, but at the same time the sensor is with the help of the interface mechanism in the car, it will be sending the data to the cloud, and mobile phone is getting the data from the cloud, and it is giving the alarm stating that, yeah, there is a problem in the engine, please look into it. It's a cloud based data communication. Similarly, we have a solar system, solar panels. Normally, when an inverter finds it difficulties, or when a solar inverter finds any kind of difficulties, the sensors will sense those problems, and the problems are directly shifted to the cloud-based, and the mobile application will receive it from the cloud, and then they intimate us. So here the journey of the data goes from different stages to different stages, and journey goes a farther network area. From your device, it goes to your interface. Through your interface, it goes to your network. From your network, it goes to cloud. So from the cloud, you can access it anywhere in the world. So it's a communication is a bigger communication rather than communicating the information over a single dashboard or a single board. So direct communication. So these IoT devices can be connected to an actuators that allows them to interact with the other physical entities. So IoT directly cannot send these devices, this information over the cloud. So it requires actuators. So these IoT devices can be connected to actuators, and these actuators allow them to interact with other physical entities, including non-IoT devices and systems in the vicinity of the devices. As I already told, a relay switch can be connected to an IoT device, which can turn the device on or off based on the command given by the IoT device. See here, IoT device is not controlling. Here the relay is controlling. So an actuator is actually controlling. For actuator to do the service, you require the IoT's help. So this is the joint venture of IoT along with the actuators. So now let us look into the different types of IoT devices. IoT devices could be wearable devices, IoT devices could be available in the smartwatches. IoT devices can be of LED lights. IoT devices could be of automobile and industrial machines. You could find out IoT devices in automobile and industrial machines. A current two-wheeler, electric two-wheeler, if you take Ether, if you take TVS iQube, or if you take a car, most of the automobile industries, industrial machines are having IoT devices embedded in it, so that remotely they are able to manage the things. So